Good evening. It's Monday, June 1st, and this is Nighttime Mathematics Radio. Well, we're once again in this world. It just gets weirder and weirder, but the one thing that just keeps going is the math homework. We've got protests all over the country. We've got COVID still hiding in the background. We've got classes all still just on Zoom meetings. We're all under curfew for various amounts of time. And yet the math homework just keeps going and going. Well, we're in the last 2 weeks of the show here, so let's take a look at a problem that came in over the break. Once again, the show always has the same format. If you have questions about math that you're just stuck on and can't figure out how to handle this weird world, tweet your questions to me here at Night Math Radio on Twitter, and I'll try to answer them live on the air. The question we got tonight for tonight's show is an interesting one. It's deceptively tricky. When you first look at it, you think, this is nothing. I can do this. It looks like this. Please tell me what 1 plus the integral from 1 to infinity of dx over a to the x plus 1 is, where we're given that a is greater than 1. So this thing at least converges. So how do we compute this thing? Well, that's going to get us into a maze of twisty little bits of math. So let's take a look. First thing, we've got a messy thing in the denominator. So let's start with U substitution to clean things up a little bit. We could say, but before I get going, actually, we should do one thing, which is, while it's common practice to write an improper integral like this, one that goes out to infinity like this, let's be careful about this whole thing. You really write this properly. Is the limit as capital X goes to infinity, the integral from 1 to capital X of dx over a to the x plus 1. The reason I'm doing this is, as we go through this problem, you'll see we'll get to a bunch of places where it's incredibly tempting to split up the integral into a difference. And if we do that, we're going to discover very quickly that we're going to end up with infinity minus infinity, which is an indeterminate form, and that's ugly. So let's keep that limit outside to let us work the problem first as best we can all the way through, and then impose the limit. Because as long as we do that, we won't run into trouble. So this is one where great care is called for. Now let's start with the U substitution here. Let's say U is equal to a to the x plus 1, just to get a nicer denominator. Well, okay, we can do that. If we do that, then what's du? Well, du is the derivative of this thing. Well, what's the derivative of a to the x? And you may not remember this one. It's a to the x times the natural log of a dx. Where does that come from? Well, let's take a look. A to the x is equal to e to the natural log of a to the x. Because after all, e to the x and natural log are inverse functions, so if you apply both, you get back where you started. We can pull the x down using the usual properties of natural logs, so that's e to the x times natural log of a. Now, if I want to take a derivative of that, it's fairly easy, because you just use chain rule. That's derivative of e to the something is just e to the something, so it's e to the x natural log of a times the derivative of the internal function, which is, in this case, natural log of a. And there we are. And now we can immediately rewrite this as a to the x again, so let's a to the x natural log of a. So great, we can plug in this U substitution, and what we get is, this is 1 plus the limit as capital X goes to infinity, the integral from a to the lowercase 1 plus, a to the 1 plus 1, that's u. When x is 1, u is a to the a plus 1, up to a to the capital X plus 1. I'll put little square brackets on my little big serifs on my capital X so I can tell it apart from my lowercase x. Of, well, dx is du times, du divided by, I should say, natural log of a times a to the x. So we've got that down here. And that times u in the denominator. But of course, we don't want an x in this, we just want u's. So that's 1 plus the limit as capital X goes to infinity. The integral from a plus 1 to a to the capital X plus 1. du over natural log of a times, what's the thing in parentheses? Well, that's just u minus 1, because that's a to the x. U is a to the x plus 1, so a to the x is u minus 1 times u. And now I can pull that log a right out of the integral. So that's the 1 plus 1 over natural log of a times the limit as capital X approaches infinity. The integral from a plus 1 to a to capital X plus 1 du over u times u minus 1. Great. It may not look like it. We've made some real progress here. Now we can use yet another trick. This is an integral problem that requires trick after trick after trick. It's kind of lovely that way. So how do we do this trick? Well, now we say, I'd like to use a partial fraction expansion of this. How do I expand 1 over u times u plus 1? Well, I know that must be something over u plus something over u minus 1. That must be equal to 1 over u times u minus 1. So we just have to figure out what the somethings are. Well, you can see the common denominator is u over u minus 1, so this will become au minus a. This will become bu, so it says a plus b times u minus a is equal to 1. So a must be equal to minus 1, because there's no u term up here. And a plus b must be 0, so b must be positive 1. So let's just rewrite this whole thing again as 1 plus 1 over natural log of a. The limit as capital X approaches infinity. Integral over from a plus 1 to a to the capital X plus 1. And now we just have our two things. We have du over u minus 1 minus du over u. And we can pull out the du here to make that a little more sensible. 1 over u minus 1. And each of those is easy to integrate. By the way, this is why we're being very careful with the limit. It's very, very easy. If you leave infinity up here as if infinity was just some number that you happen to know, this whole problem gets really hard. Because you end up with infinity from this, infinity from this. My head hurts. Let's try again. We end up with 1 plus 1 over natural log of a, as always. Integral from a plus 1 to a to the capital X plus 1. And there's the limit still there. Limit capital X goes to infinity. Well, what is that? That's the natural log of u minus 1 minus the natural log of u. And now we've done the integral, so actually the integral shouldn't be there anymore. I've done the integral. That's evaluated from a plus 1 to a to the capital X plus 1. Now we can use properties of natural logs to put this together a bit. So that's 1 plus 1 over natural log of a. Limit as capital X goes to infinity. Natural log of u minus 1 over u. So it's u minus 1 over u. And we can just do that division. A plus 1, a to the capital X plus 1. We do the division, that's... Oops, let me go just quickly scooch on to the next page a bit so we can see where we're going. That's 1 plus 1 over natural log of a. The limit as capital X approaches infinity. Natural log of... Let's see. 1 minus 1 over u. Evaluated from a plus 1 to a to the capital X plus 1. Well, we can plug in those limits and see what we get. At the upper limit, what is this? This is 1 plus 1 over natural log of a. The upper limit, which is natural log of 1 minus 1 over a to the capital X plus 1, minus the lower limit, which is the natural log of 1. Sorry, not 1. 1. Being stupid. 1. That's not 0, that's 1. So it's 1. Let's rewrite this last bit. Minus natural log of 1 minus 1 over a plus 1. And see, now I can take that limit. And the limit where x goes to infinity, because this is all in the limit where x goes to infinity, capital X goes to infinity. This first piece, this becomes 1 over large, so this becomes small, so this becomes natural log of 1, so this first term just vanishes. Boop. 0. So this becomes 1 plus 1 over natural log of a times minus natural log of, well, that 1 minus 1 over a plus 1. Well, we might as well have a common denominator here, so that's a plus 1 over a plus 1. So that's a plus 1 minus 1 over a plus 1. These cancel, and we end up with 1 plus 1 over natural log of a times. And now here what we would have is minus the natural log of a over a plus 1, but since a minus of a natural log is just 1 over, it's just the natural log of its reciprocal, a plus 1 over a. And now we're actually done. That was a fun, messy problem. It involved a lot of different kinds of lots of different integral tricks. Oops, let me move the camera over it so we can see that last piece. And that's where this thing ended. Oops, if the thing will ever, come on, darken back in again so we can see it. There it comes. That was a wonderful problem. It involves all sorts of interesting things. It involves tricks, properties of logarithms. It involves partial fractions. It's a fun problem. Well, this is Nighttime Mathematics Radio. Looking back at Twitter, we see that... Looking back at Twitter, if I can, we see that no new questions have come in, so I guess that's going to end tonight's show. So everybody, stay safe out there, even more than normal. For those of us in the United States, it's an interesting sort of day. But whatever else is happening, the math problems keep going on. So stay safe, everyone. Have fun and keep doing the math. See y'all tomorrow.